In this lecture, we're going to talk about the question of finding what is nearby, and mainly we're going to deal with the buffer zone analysis, which is very widely used for risk analysis and risk modeling. We're going to cover some of the ideas of what is nearby, what is near mean, and how can we actually model the nearby concept in ArcGIS. In geography, we know there's we call the first law of geography, stating that things are all related in the world, but those things that are nearby are more related than the things that are remote, distant apart. Okay? So many of the interest in data or in the phenomena are based on the nearness, okay, the proximity concept. Okay? So there's many reasons you may want to study nearness or kind of nearby things because you want to monitor events that may impact you. For example, the crime near your neighborhood may have implications on the safety of your house. Okay? And we may also want to find out the available services, for example, nearby hospital, nearby schools, nearby shopping centers. All these are kind of needed facility for daily life, right? And we are always interested in finding things what is happening nearby. Right? We can also maybe also interested in the nearness due to the spatial spread of pollution or disasters. Okay. So any of the chemical spill could pollute the area surrounded, okay, and disasters tend to impact the most to the surrounding areas. Right? Although that impact will probably diminish as the distance go with the distance. Right? So we try to capture that sense in understanding and analyzing what is nearby. And understand the purpose. Okay? So most importantly is to know when and how to apply the techniques finding what is nearby. Well, near is a common sense concept. Okay, so we have an intuitive understanding what the near mean given a particular scenario or situation. But if I ask you what does mean by near in the kind of clearly explicit stated way, you may have difficulties. Okay, so in general, we basically don't have a good way. We can just vicinity of a certain feature or landmarks. Okay, but the most important part of this nearness is that the things are not in the same place as your interest, but kind of have a little bit distance. The important thing is that within that distance, within the near definition, things are considered very differently from things that is outside of the near concept. Right? So you may have a radius of maybe half an hour drive that where you are willing to take a trip and participate. This will be defined as near because beyond that you're probably not going to go. So location and many cases transportation manner and available kind of destination also kind of play an effect. Okay? So on what is near. Okay? So with that kind of general understanding, we have to let the computer to model what is near at this moment. There are generally three ways to find out what is near. The first you want to consider is to use the select by location. Okay? So because select by location techniques actually allows us to indicate the selection of features that are close to another feature with a distance relationship. Okay? Think about that option first, but select by location only help you to highlight, select the report, the features that are nearby. The second method to decide what is nearby is to say we first define the areas of nearby and then see what are the features for within that area. Okay? So this method requires us to define, to calculate buffer zones, okay, or buffer area based on certain distance criteria. We have to define what is near in terms of distance. Okay? And the third method we call the nearest neighborhood method is more kind of not about what is nearby, but is what is the nearest, okay? Nearest in a sense. So we're going to mainly cover the first two methods, and we already covered some of the methods for the methods one already been covered in previous lessons. So actually the buffer analysis becomes the focus for this lecture. The two methods we talk about, select by location or buffer zone analysis, they have some differences in terms of the usage. So we need to understand that select by location doesn't really output anything until you try to generate a report. However, the buffer analysis tools will automatically create a new layer that including those buffer zones. Okay? This is very useful if the buffer zones you try to define is going to be used in multiple analysis where you have this buffer zone already generated, and that makes the analysis more kind of useful. But select by location is more temporary. You don't have a storage of the results until you maybe you can save the export the data, the selected subset into other layer, but it's not guaranteed. You have to do that yourself. So two methods have very different use, and we need to be clear when to choose which. Select by location using the within distance of as a spatial operator actually used a similar concept of buffer zone, but it didn't show that buffer. In general, the system will generate an internal buffer that will be used to detect any overlap with other features you want to capture. So in this case, we have this parcels data, and we also have this probably we can call it a pollution area. Right? And by having defined the pollution area as 1,000 feet, okay, then we can actually identify those parcels that are either partially or fully overlapping with this particular area. Okay? So select by location will work to find the nearby thing, but they are not going to be very precise and accurate. Okay, some of the features may complete outside or almost complete outside. When you use a select by location to find out what's nearby, we need to actually be able to choose from the number of spatial operators. Okay? So the particular operator we need to use is called within the distance of. Okay? So please read that kind of statement whenever you apply that rule. And the second thing is you need to be aware that what are going to happen with the selected features after the spatial operators is executed. Right? So basically, the features that get selected are all within certain distance to a predefined feature, and the result will be simply visualized the selection as highlighted on the screen. Okay? And if you want to use them permanently for other purpose for the selection, you better save it, okay, or export it into a standard or kind of regular shapefile and make that available to subsequent analysis. The concept of buffer analysis is very straightforward. Basically, we take the input feature and create a buffer depending on the given distance, and then for the analysis of what's nearby, we just make a second step to see what are the features inside that buffer zone. For example, we could have distribution of crimes that along streets, major streets. Okay, then we can see how many crimes that are within 100 feet of major street network, and that will give us idea how the distribution of crimes are correlated with the street. So in Geographic Information System, ArcGIS, there's kind of a buffer dialog where you can actually select the input features together with the distance of the buffer. So make sure that the unit of the buffer distance is appropriate. Right? Many of the difficulties of doing buffer analysis is to decide what is the proper distance for deciding the buffer. Right? Because in many cases, the concept of near is a cognitive concept that when you match to or map to the real number or accurate number, the number is approximation of that near concept. And that may or may not be known prior your analysis. And in some of the cases, you could do multiple of this buffer and then do some sensitivity analysis. Okay? So you could do maybe between 200 feet and 400 feet and 800 feet and 1,000 feet, so that and see how these changes of distance will lead to some answers may be different. So that's the difficulty, but we can have more discussion over there. A buffer is an abstract concept that represents kind of conceptual objects. However, when the buffer is interpreted in different applications, they could mean very different things. For example, if you study toxic spill, or you study kind of land use and zoning, or you study earthquake risk, like the project is doing, you could end up with a very different sense of buffer, okay? Whether the buffer should be one buffer or multiple buffer, whether there's a concept that already dictate what the buffer will be, okay? That's very important implications for any analysis. Doing buffer analysis with ArcGIS takes a number of steps. When you start the buffer utility, the dialog box will ask you a number of questions, and you basically have to make those decisions. The first question is, what is the feature that you want to build buffer around? This feature usually is the source of some influence. For example, it could be some contaminated station, or it could be a pollution source, or could be the service point where the service area is defined by the buffer. So this particular input feature can also have features that selected. Okay, if you have features that only selected, the buffer will be built on those only the selected feature. Okay, if there's nothing selected, the buffer will build on all the features in that layer. And then you basically have to tell the system where do you want to output your buffer features to a place. Okay? And in this particular course, IST 868, we have your individual folders under the UPFS1/VA/IST868, and each one of you should have a folder that you can store that layer. Okay? If you can do that, try to store everything that relate to this course to your personal folder. And then we come to the decision that have to make a choice on what distance. Next step is to decide on the buffer distance. This buffer distance should be reflecting the concept near to that particular application. The distance involves both a number and the unit. Make sure the unit is correct, is selected right. One of the reminder for doing buffer analysis is that your map feature or map data must be projected to a planar kind of a coordinate system, because that's where the distance measure exists. If your data was not projected, still taking the latitude and longitude by degrees, we call them non-projected data, and those kind of data cannot have a measurement by distance. So again, I think the buffer analysis, the difficult part is to decide on the distance measure. Step 3 is to choose the names of the output buffer. Please give a meaningful name so that you don't forget. Okay? You could choose something that based on the feature name, and adding some kind of appendix, for example, above. That's kind of a regular naming convention, so that you know it's not a feature but it's a buffer. Okay, and also you can export into either shapefile or the geodatabase. Okay? Normally in this particular class we just use average, the plain file system shapefile. That's sufficient. Okay? We also need to look at whether we want to dissolve the feature as if there's a neighboring buffer that overlap. Okay? If that the buffer, individual buffer doesn't matter, and you just look at the overall areas of the buffer, dissolve can help you to reduce the complexity of the results and reduce the storage, and also make it easier to do summary. Okay? So consider what choice you're going to do with the dissolve type. After you answer those questions, you're basically ready to run the buffer analysis. The program basically will generate this buffer area as a polygon feature, and then add this new output layer back to your map. Okay? So the color of this buffer zone is initially random, so you can actually change the symbol to be something meaningful, whether it should be green or it should be red. That's up to your application requirements. Last, I would like to mention some relationship between buffer analysis and the risk analysis that we commonly do in the intelligence community. The risk, okay, of any hazards or any kind of hazardous events depend on the distance. Okay, the more distance away, the less of the risk. So when we decide what areas we should be sending out warning messages, what area we should send troops or first responders to those special events, depending on how much is the perceived risk in this based on distance matter. Many cases the risk is not kind of a crispy. There's no crispy boundary between risky areas and non-risky area, but instead it will be a grade of high risk and low risk area. Okay? So doing such kind of estimation of risk can be assisted by doing multiple buffer analysis of different distance. So, for example, we could choose 3 or 4 distance from smaller buffer to larger buffer, and those different polygon representing buffer will represent a different level of risk. Okay, if you do it well, you could generate risk surface by coloring them differently, okay, from warm color to cool color. Right? And you can also decide on the percentage of the impact features by those buffer analysis. So this is something we're going to practice in our projects, and hopefully that will show up some kind of interesting risk model. To make multiple buffers and creating risk surface is a really fun thing. Definitely you can always use the tool to make a single buffer and run the program multiple times with different distance. Okay? However, the ArcGIS provide a special tools that actually can make the multiple buffers easier. Okay, if you use the ArcGIS toolbox and doing the proximity analysis tools, and you're going to see there's a tool called a multiple buffer analysis. When you open up this dialog box, it allows you to choose the first thing is the buffer feature, and then you can indicate the multiple distance. Each of the distance will correspond to a buffer that's representing that kind of buffer area. So your output will have multiple buffer rings, okay, and each ring will be tagged with the distance. So this is very effective. Here we show the results of doing buffer around the fire station and indicating what kind of relative strength of service from that fire station. With that, I want to conclude this lecture by saying that finding out what is inside, what is nearby, have two forms of analysis. One is select by location, and the second is the buffer using the buffer analysis tools. Which one is appropriate depending on the purpose of your analysis. Normally, buffer analysis can generate the concept near in the permanent storage, and you can use that for multiple analysis of what's nearby. Select by location is more temporary, but you can also generate the output of the features, okay, and store them. Both of these two analysis give you visual presentation. Okay. The select by location doesn't show the buffer area, but it uses it implicitly. So if you want to be visually showing the concept near, doing a buffer analysis is preferred. And we also mentioned the buffer analysis, especially running multiple buffer rings, can help to determine or to calculate a risk surface, and really use that to study the sensitivity of your risk analysis towards distance measures.